This session is going to be we already released the summary lectures for week 12, which includes I think up to week 6 summary was released. So I'm going to go through by weeks onwards. So if we have any doubts on specific content, we'll stick there and clear out the doubts, or else we'll move on to next topics. Okay, I am skipping week 1. We will start with complexity. Okay. Does anyone have any doubt in this topic? Any clarification? Primarily, there are two types of complexity. One is time complexity, another one is space. What we call it as an asymptotic complexity. Okay. Actually, I'm not. This session is not about just for a clarification of doubt. I mean, your doubts are anything is needed. I'm not going to go through every topic by topic. I mean, in depth or detail. So, if you have any doubts in between, please ask in between.
Hello, sir.
Yeah.
Sir, can you discuss the programming part? I mean, the GRPS. Can you discuss the logic in which we should approach the problem? That thing.
Okay. In which in week 1? Sorry, in week 2.
In week 2, 3, and all. I mean, all the weeks the difficult GRPS. I mean, 1 or 2 are not. I mean, not easy, but it is okay. But the 3 GRPS of all the weeks.
Oh, okay.
I mean, how? I mean,
I'm
any
not
approach
going
on.
Okay,
Yeah.
I'll give the approach, but not going to go through all the GRPS.
That would be better because theory part is clear. I mean,
Okay.
pretty much clear, the theory part.
Okay, sure. Can you specifically ask me any specific GRPS? I'll explain that.
Yes,
In
sir.
We'll go by week onwards. Is there any specific GRPA?
Yes, sir. GRPA. Week 4. Can you discuss the week 4 GRPA?
GRPA? We'll ask others also. If there is nothing to be discussed on week 2, then we'll go to subsequent weeks. We go by order. We'll finish it up 1 week and.
Yes. So the Srinivasan here. I don't know, maybe it is just my lack of understanding. Somehow, almost every question that talked about what is the complexity of this algorithm, right? I seem to have got it wrong. So I was just trying to look at my question paper. I think it's a question paper. And so there's some basic concept I seem to be missing about the complexity of algorithm, right? Between n and n square and log n. So
yeah, sure.
So how do you, so suppose you were given an algorithm. So the only way to look at the complexity is how the professor has said, right? You have to write each step. Most of them are recursive, so which means you have to write each step and then build it up.
Yeah.
Is there any other method? Is there an intuitive method, or this is the only method?
Yeah. One more intuitive method. One more method is there, which is introduced in the later weeks, right? That I think it's in
recursion tree.
Yeah, recursion tree.
Okay.
Yeah, that's another approach.
Okay.
Yeah, and week 8 recursion tree. That's one more intuitive method, which is basically work on recursion. If it's a loop, it's very obvious.
Okay, so I'll try. I don't think I did not use, because even this 3 also I got that wrong.
Okay.
Right, all that.
Okay.
Somehow I just, there's always been a combination of questions, right? Some ask for ON, some are n log n, and consistently I get them wrong. So okay, I'll practice.
Okay, one more thing about this complexity thing is, if there are two variables, you have to consider it. I mean, let's say there are two values m and n. Then if somehow if your complexity is involving both, if there any specific relation between m and n, then you can write in terms of any one variable. Or else you have to explicitly state the complexity based on both of them. That's one more thing. In some cases, like in a graph with the m stating the edges and n being the nodes, we can assume that m will be at max equal to n square. Sorry,
yeah, n and n minus 1 by 2.
At most n square. So in that case, we have some relations. So we have to keep think of that as well. Yeah, otherwise, just to in the whatever the recursion case, right? Just imagine how the recursion tree is growing. I mean, whenever the splitting happens, I mean, how much the splitting is going on, you can come to know based on the function, right? One function, apart from the recursive thing, this merging or whatever doing, some external operation is doing. You have to take care of this. Also, go through how it's diverging and what are the things we are doing. Let's say one is split into 2, and again it is split into 2, again split into 2. So it's multiplying. Also, are we going through all the nodes?
Okay.
I mean, these are some intuitive way, but at the last, if you approach the way which started in week 8, the recursion trees, right? That also works. These are some intuitive ways. Let's say if you are not going through both of the trees, then it's a binary search. If you consider the binary search, it will come in log n, because in some case it will not. Okay. These are the region we are going to search for. We fix the midpoint. Then we have to decide, take a decision whether I should take left at this region or this region. So after all, we never go back there.
Yes.
Yes, but if it's a merge sort kind of thing, you have to solve them independently. You split it and we solve it independently. So either we are going through all the nodes, whatever the elements there, we are doing them.
Yes. Okay. So one is divide and conquer. Obviously, we can do everything, but partition and go will, as you said, binary search, because you are partitioning it and looking at only one part. So okay, I get that. Okay.
So there was a question based on this in quiz 3, I think question number 18 in PDSA.
Okay.
Could you?
Yeah, it's a different 6 spike. I also forgot which one. There is one thing which is ON square and ON log n square, and I got that also wrong.
Okay, I think subset some question.
Yeah, each subset is different, right? So
yes. Okay. If possible, sir, could you
So it's based on which week?
I will.
Yeah. I mean,
Quiz
we
3.
are quiz 3, right? I mean, there will be one more session for week 7 to 11.
Oh, okay.
Yeah, this session will cover up to week 6. After
Okay.
that, we will cover from 7. One more session which will cover 7 to 11.
Sir, so can you take one complexity analysis based on quiz 1?
Yeah.
So in quiz 1, there is a question called mystery function. Can
Okay.
you discuss that? The question number 4.
Okay. Just I'll take.
I'm pulling up the question. Because each paper could be different, right? Yeah.
Yeah.
It's the set 2 question set 2.
Okay.
See, the second question is actually the simple one, selection start. I think that's what you're not talking about. That. Do you remember which question it was?
Yes, the question number 4 and 5.
In set 1 or set 2?
Must be the other set.
Set
Okay.
2.
Set 2.
Mystery function. Yeah. This is QPD, not C.
Okay. The question number
4. There is a mystery function.
Okay.
Actually, when I first saw the question in the exam hall, I just lost that. How can I do this problem, this kind of situation? So you just discuss the approach, that how we should
Okay.
start
Yeah.
answering this.
Yeah. How is it ON square? Right. That is the question.
Yeah. One thing in complexity analysis that I can thought that first we have to check that it is divide and conquer or not, it is dynamic or not, and iterative or recursive. That will be the first view, and then what should we do?
Okay. Yeah. Just
Like it is not the divide and conquer or such kind of thing. It is just normal recursive. So in this case, how
okay.
should we go?
Before I am saying anything, just go through this code for yourself. Take some minute. It is already you seen in the throughout the course. You already seen the program somehow. You know this. Just go through this code, and I'll take some minutes and understand what it's doing one more time.
Yes, sir. Now it is looking a little bit, doable. We can start this. But I don't know why in the exam hall then
Yeah, I get
I
it.
didn't
Did
get
you
it.
know what is the program represents?
Yes. The V will if the all the LL is all the elements. If the element is less than V, and LV is the all the elements in L which are equal to V, and LR is the greater than V.
There is
And
a
then
specific algorithm name. This algorithm has a specific name. Have you get to know about that?
No, so I don't think I.
No, just okay.
It's like the binary search, I think.
Yeah. Okay. What
Like
that
that.
LL represents, right? anything the value less than v. Okay, all the
Yes.
values which have less than v stored in LL. LV is the which is equal to v. LR is the greater than R. At the end of the it is returning only one value. That is to be clear. If it's k is greater than the length of LL, then we are searching within the mystery function using the LL. We are searching within LL. If it's equal to this pattern, this thing, you saw somewhere here. Just to recall it. I mean, you know the name. If I say the name, you will be obvious. Just understand what it is doing. Just see this thing. This 3 line. You're already familiar with this algorithm.
Okay. If the number of elements which is less than v, if the number of such elements is greater than or equal to k.
Yeah.
So this is like a quick sort. Basically, it's trying to find a pivot and.
Yeah, clear. But are we starting here?
We are not sorting. We are selecting. Quick
Yes.
select.
Oh, yeah,
maybe.
not,
Yes, it's
not
a quick select
sorting.
algorithm. It's exactly in the quick select. I mean, one different way of implementation.
Okay. And in a quick select, okay, the question asks about the worst case complexity. So the worst case is because you're looking for the wrongest element.
Yeah.
Right. In an ascending this thing, you're looking for the
Worst case.
Worst case.
In the we know that quick select works on in the worst case was n square, right? If I say, obviously we know it will be of order n square.
Okay.
Yeah. Either way, it's all about the and that pivot we are setting, right? That k. Yeah. Now we.
Okay. And then in this case, since we are not dividing, there is no partial part. Log n is not an option at all, right?
Yes.
It'll never come, no? Log n will only come when you are actually doing this partial.
Yes. Also, in every function, right? In whatever the branching out, we are doing an order of n operation there.
Okay. Yeah.
Yeah. So that brings that complexity.
Yes.
The order of operation every iteration. So if you've gone through the order of at max by n times, which is n is the length of the list L, then will be an order of n square.
Yeah. So
Based
here,
on the
anyway, in this question, only B and D are the only things to even consider. N or n square.
Yes.
The log n will not come. Okay.
Yeah.
But then
I mean,
have...
the thing is, just go through the question and pick. Don't choose the option by yourself. I mean, don't look into the option. It's my advice.
Okay. Okay. I get the point.
I mean, it is not for any option based question. Just first go through the question, understand, and came up with your own answer. Then go to the option. Whether your option is your choice is there, your selection, whatever answer you came up with, whether it is there or not. Then make the other decision. Should the other options are correct or wrong.
Okay, got it, sir.
Yeah. I mean, but there are some questions which requires in a back way by using the option or like that, but it's on standard.
Okay.
Anything in week 1?
Week 2, actually.
Sorry,
yeah, no,
anything in week 2?
No, sir. Other than that, no.
Okay. Okay. Go to week 3.
Yeah, this question is not in my paper. Otherwise, I would have got this question wrong.
Okay. Whenever it comes to complexity, right, just take over how the flow is going, all those things. Calculate the complexity in between as well. Those are things. Okay. Yeah. I mean, whatever the question we are giving, we'll give it as much as straightforward without using any much of any other function which requires complexity. We try to do as much as possible.
Okay.
More reference you have in it's required for the overall summaries be provided in week 12. Always refer the slides as well. I think the slides also provided for you.
Yeah.
Okay. Okay. The week 3 is mostly about week sub. Also we discussed here as well. Okay. One important thing which I have to say here is that hashing thing.
Mhm.
Sir, before starting week 3, can you discuss the GRPA 3 in week 2? In place merge.
Okay. GRPA 2 in week 2, right?
Week 3.
GRPA 3.
GRPA 3 in week 2.
Okay, sure. Okay, it is the code. Okay. But actually, this question is more of a constraint type question.
Yes, yes. Only swap function is allowed.
Yes. Okay. 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 First thing, we have to find the smallest list among A and B. So if it's any one is less than one, which is an empty list, we'll simply returning it. Okay. So it's already very well commanded. If A and B is already sorted, B of 0 will be at least in B. I mean, so this thing, it says the first element will be stays in B if A and B is already sorted. So what we are taking is, we are taking the first element, I mean, we're going to take the element I. If it's greater than B of 0, then we are moving it to B. I mean, simply we are swapping those elements. After the swapping, we have to know, okay, first this swap does between A and B should be decide that element which should be present in A or B. Okay, so then after coming into B, we are just moving that element to accordingly which place we have to set it on B. It is just like a insertion shot, which we are doing here, right? This part.
Okay, so main concept is we will iterate over the smaller list, and for which element if it is less than the element in the first list, then we will swap it.
Yes.
Okay.
I mean, whenever you do this, right? If you are iterating on a smaller list, then it's one big list, or if you are iterating a small list, after gone through, you are seeing the I mean the minimum of the value. If it's not a minimum, it will be swapped.
Yes, and not like the recursive algorithm in merge sort.
No, not like that.
It's
Whatever
only
we
the
are doing here, yeah. The first stage, whether we should, I mean, move an element between, whether we should swap anything between A and B. That is the decision we are making. If A is greater than B of 0, we are swapping it because we already found one minimum value in B. It's
Okay.
2 here and B. I also found one, so it should be
Okay, so here,
swapping it.
in compared to the original merge sort, the recursive divide part is not here, right?
No. Actually, we are not dividing anything or like that. It's simply we are iterating.
That's why I'm asking that it is the difference.
Yeah.
Right.
Yeah. Okay, if you are referring to divide and conquer, right? If you are dividing, you have to solve them independently. Okay.
Yes, not in place.
Yeah, you can merge it afterwards when you are combining or whatever the operation we have to do, but you are solving them independently of each other.
Yes, and what will be the complexity of this algorithm?
Okay. It will be order of m1. Yeah, the for loop will it will be order of m. Within
Okay,
that,
so
yeah.
for same size, it is n square.
Yes.
Okay.
But yeah, the upper bound will be like that. But here we are doing the trick like insertion start, so it won't take always take order of n times.
Yes,
Because if we
but
always
so why we are calling this merge sort? I mean,
actually,
because merge
what
sort
we are
is n log n. Merge sort
it
is
is
n
not
log n.
merge. It is not merge sort. It is merging two sorted arrays. It is not we are sorting based on merging and sorting. Here, what we doing is we have already we have two sorted arrays. Whatever the array A and B, it is already sorted.
Okay.
Yeah, it's like 2, 3, 4 in A. B will be like 1 and 5. So I'm merging two sorted arrays.
Okay.
Yeah, but the main thing of this GRPA, what it's targeted is, you are doing it as in a in-place thing. You are not using any other thing. Let's say I can come up with one easy approach. Let's say A and B. I create one more array, take the least of 2, and I am appending it.
Yes.
Yeah,
That
that's
was
a very obvious
original
approach. Yeah.
Yes.
But the thing is, you are not allowed to use one more list or array there. Okay. So you have no choice. You have to swap in between. Yeah.
Is the previous merge sort was the merge process in the original merge sort, it was in order of n
Yeah,
only.
it will be order of m plus n.
Yes, order of m plus n.
Yeah.
And this is order of
Yeah, m.
mn.
Yeah.
Okay. So, but why mn is coming here? I'm not getting it.
Okay.
Okay, so for each the element in the bigger one list, we have to check all the elements in the another list.
Yes, it will be order of m.
Yes, sir. Got it.
Okay. Is it clear?
Yes, sir. It's clear now.
Okay. Just more. Okay. I'll go to week 3 and the dictionary implementation.
And sir, for one thing I want to ask, that if I have to sort some list,
Okay.
can I use any sorting algorithm, or the question may be mentioned for one particular sorting algorithm?
Unless it is mentioned, you can use anything. I mean, in general case, you can use anything.
Okay, so
I mean,
so
if it's
for
if it's the question is not targeted for sorting, right? Then you can use anything. I'm fine, whichever is more appropriate.
okay, so if I use one thing like merge sort or heap sort, so any one sorting n log n sorting algorithm
Is enough, yeah.
will be enough.
Also, it depends on the case as well. I mean, more than that. Okay, let's say there are a group of students. They have to be they should be. They have each have some roll number like that. They have to sit on stand in a line in between on the order of their roll number. Okay, like a 0, 1, 2, 3, 4, like that. But you find, but somehow some students will swap the places with the next one. Let's say in this case 7, 9, 8, 10, 12, 11, 13, 14. These two swapped the places, these two swapped the places. I mean, it occurs rarely. In that case, what is the most appropriate sorting algorithm you would suggest?
Is it heap sort or?
Okay, that will take n log n. Can you come up with, can you select any better sorting algorithm? Just go through the whatever the sorting algorithm you have seen so far. Just go through. Just take a minute.
Yeah.
So merge
This
sort, how much time will taken by merge sort?
insertion will be faster, no, for this?
Yes. Yeah. Okay. Merge sort will take n log n, surely. But if it's a case, right? If it's an insertion sort, it will be like order of n. If you our target is a sort in ascending order, you are giving a array which is already in ascending order, then the insertion sort will take order of n. But even in this case, right, these elements are not moved. These are not far apart. So simply a swap is enough. So it will be much closer to order of n.
Okay.
Okay, okay. And if the 7 was in the after 2 and the 8 hours after 14, such kind of thing, then
Yeah, it will take more
insertion.
time. Yeah.
Okay, okay.
I mean,
So
yeah, please continue.
okay, I think it is useful to remember the worst case,
Yeah.
best case, average case for everything.
Yes.
Like
Even
selection start, I think everything is same, but I think insertion and quick, they vary. Okay.
It doesn't mean a sorting algorithm has the upper bound of n square, which is bad or like that. It has some advantage over some specific cases.
Mm.
Yes, yes.
Similarly with the merge sort as well. Merge sort is primarily used when, let's say, if your data was in some other like a complex CD or DVD or like that, then you cannot do in place there. In that case, you can use merge sort.
Yes.
So anyway, it will take some time. So in that case, if you are doing a quick sort, right, quick sort, any other sort, you have to copy those elements into a, writable medium or like into your hard disk or anything. Then you have to do the operation. If it's a merge sort, you don't have to do that. Simply read it and as it go through it, assign another list here. You can do the sorting from your hard drive onwards. So that in that kind of case, merge sort is preferred.
But it takes extra space. Okay.
Yes.
That's a trade-off. Yeah.
But in that case, any algorithm which you are using, it will take an extra space in your hard disk. But you are reading a memory from an external device. Okay. Yeah, anything about any doubt about sorting so far?
No, sir.
Okay. Yeah. One more thing. Before I come into that, you have to know you have to always take the maximum value. You have some like a number 0 to n minus 1. You always want to take the maximum value of it. But you already know that value was already pre-known, it is not unchangeable. There won't be any dynamic change into that whatever this ordering. So what is the data structure you would prefer?
So can you repeat?
Okay. You have some numbers, okay, which is already ordered. Let's say there are let's say these are the students with the roll numbers 0 to n minus 1. You want to call the students whoever is the last roll number. Let's say you want to first pick the n minus 1 student, call him. I mean, you are doing some like a teaching or something or like that. Then you have to call the n minus 2 student. So in this case, what is the best data structure you would prefer?
Heap.
If it is, I think it should
You are
be
taking the
a
max value.
simple
Max.
array.
Yeah.
We can use the simple array, no? Because if it is sorted already, then
Yes, exactly.
we can use the simple array just.
Yes. You said initially you think of heap, but heap is a more usual when it is a dynamic
Change.
dynamic practice. Yeah.
Okay.
If it's a static thing, you can always use a simple sorted list, which is enough. You can always pick the last element, which will be an order of 1. But if you are using heap in that approach, you have to heapify, it will be order of n. Then you have to picking all the elements will be n log n. Okay, then we'll move to hash table. Okay. In general, what we do in a hash table is we take one value and we map it to some key, I mean, some hash value. Let's say the simplest approach will be like a modulo operation. Say x mod 10, simplest, it will produce a lots of collision. And let's say x mod 10 is the x is the value which I am taking. X mod 10 is the where I am storing. So how I am doing is there are two approaches. One is open addressing. Which is also closed
hash.
Closed hash. So what you do is, let's say you have only 3 values, which are 3, 13, and 15. It is your hash function. Okay. If it's a open addressing, what you do is you take the 3, that value will be comes 3 more 10 will be 3. So you are placing the value 3 in here in your some array, your storage location. Then you are taking value 13. You want to store inside the hash map, but that hash value gives the same value 3, which gives a collision. So what you do is in open addressing, you'll go and find the next dot. You're searching for other sort. So you are finding value then. So you are placing here. If it's a 15, then it will come directly to 5 without any, because x mod 10 will give 5. So you are directly placing the value here. Also, very important thing about this hash mapping is the value should be immutable, because whatever the value you are generating, the hash value you are generating, which is based on the individual value. So if it's a list or a dictionary which is mutable, then the hash value will change. You cannot find the find based on that hash value. Okay. Another approach
like the dictionary key.
Yes. Yeah, dictionary is more like a hash map only.
Yes.
You understood, right? What is open
Yes,
addressing?
sir.
Okay.
And this is even for strings, right? You can't go change a string by indexing.
Yes. Okay, I take the same value. If it's a open hashing type, right? Then if I will take the same x mod 10, I'll take 3, it will stay come here, and if I take 13, it again come here. So in open hashing, we won't store it immediately here. What we there is, it will point to some list. Whenever some value comes, we are simply appending it. Then
Sudarshan Sah's session was very good on this.
Yeah.
He was talking about the data, and you build a.
Yeah. Yeah. So if you take again 13, it will come here and make a collision. Surely there will be a collision. So what you do, instead of that, you will append it here. The 15 will directly come here. There will be a list. So each value will point to some list. So whenever you do the searching, right, you will come here and search in the list. Yes. It's the difference between open addressing and open hashing. Okay. Anything in week 3?
Can you discuss in the linked list, doubly linked list structure very briefly? I know the concept, but when we code the cell, the previous thing we should, we should put, and the next thing we should put. Where we should put the previous thing?
Okay. Got
that
it.
part.
Okay. So far, how you are introduced in the by how SAR introduced a linked list is, you store the root value. I mean the first head value. That is the address you are storing that object. Okay.
Okay.
I'll say it's simply.
The basic concept is clear, right?
Yeah.
Yes.
So you will. It will be here the reference value for V1. Okay, this object. So ultimately, this reference is the only reference you have. That is the, let's say, linked list. You created a structure. Then this here it stores the reference value of V1. This object, not V1. This object. Okay.
V0.
Yeah, this thing. But if it's a W, it's a way Sarah used. We are using the same method. So if it's a W linked list, you have 2 values.
And in the previous thing, in single linked list, when it goes to the next, so self.next will be V1, right?
Yes.
And for this, the self.next will be V1, and V1 in V1 the self.previous will be V0.
Yes. Yeah. You have 2 reference here. You can the next will be targeted to the next object. Similarly, like that. Similarly, that previous thing will be targeted to the previous object. So you can, let's say you are like there is a linked list of a length n. Okay, you are in length n by 2. If you want to go previous value, you can. If it's a simply linked list,
yes.
If it's a one way. But if it's a doubly linked list, you can go backwards as well.
Yes, and what about the next connection of the last node and the previous connection of the first node?
That will be simply null.
Yeah.
Oh, okay. Both will be null.
Yes, I mean, if you see a none, then you came to know, oh, I came to the end point.
Okay. And the reference in the attribute that will be v0 only.
Oh, sorry, I didn't.
I mean, L equal to linked list. So L will be L will store the reference of v0 only.
Yes. I mean, if it's a simple, you are using a one class, okay, one class only. You have to refer it using that. Then you can refer it by that head value only, head value or tail value, whatever it's your call.
Okay.
Yeah, but if it's a
And
W
what
linked
about-
list, right?
Yes, double
you
linked
can
list.
you can use if it's a simply single one function, one class, you can refer it by only one address. Either it has to be head or tail, whatever it is.
Okay.
Yeah, but if you can use some other class, right? Okay.
Yes, if we use two other class like node
this
and
belongs to node. Okay, this belongs to, let's say, class are called node. Then I can create a class W linked list. I can have a variable here. Then I can keep reference of the head node. Okay.
okay.
Similarly, I can one more attribute here. I can take reference of the tail.
Okay, we can take both.
Yeah, and if it's two separate classes.
Yes.
How SAR used only one class, so you have to take reference of only one address, which is the first one.
Yes, okay. Yes, sir. Got it. And so the GRPA 3 in week 3.
Okay. Okay. Here you have to reverse the list, right? This
Yes.
reverse the linked list. So this root will points to the first node, the head node.
So the strategy should be go through the list and find the last node and then reverse it.
No. Not we are go to the last node and then we are reversing. We load on the way. By the way, whenever we go the node, right, we'll reverse it. That we change the node.
Okay, so we have to append in the as a previous pointer.
Yes. Okay, it works like it is already like this, right? So what we
Yes.
do is we'll remove it and we'll make a pointer here. That's what we do. So how we are referring is, that's a thing we are doing.
Okay. And the last node will be the head. Okay.
Yeah.
Yes, sir. It's clear.
Okay. The next will store the.
So it's simple, but still.
Yeah, it's hard to understand. It's a very compact way. Yeah. we are simply taking that next value on next, and we'll take the next to next, sorry, the root to next value on the previous.
Yes, just have to swap the connection.
Yeah.
Pointer.
Yeah. Then it is the way, it is that alternate, the changing we are doing here. It is the pre-one time we are updating the value. That's all. The second line was all about.
Okay.
Whenever
So
we say
what-
temp is equal to next, right?
Why we are updating the value, swapping the value?
Oh no. Okay.
Is not it
Okay.
enough?
This when okay. Let's say whenever you do operation, right? You need two reference. One this node. One is two nodes. Then you have to two reference. Then only you can do the operation. Whatever the
Okay.
swapping you can do, right? If you know only one node, reference to one node, you can't do it. You can't swap it.
Yeah. Okay.
So it is just an updation. Whenever we go to the next node, you will say that the temporary value will go to the previous, and the next will
Yes.
come
Yes.
to
Yes. Got it.
yeah. Okay. Anything else here in week 3? Okay, we'll go to week 4. Okay. Okay, just we have two representation that is to be clear. One is adjacency list, one is adjacency matrix. If it, can you tell when you have to use the adjacency matrix, which is more appropriate, and when you have to use the adjacency list?
If there are less connections, then adjacency list will be better. And if all the nodes are connected with all the nodes, then adjacency matrix will be better.
Okay. Okay, that's correct. And why it is?
Because I mean, in adjacency list, adjacency matrix, we can go directly to the to a position.
Yeah.
But in adjacency list, we have to traverse through all the n elements. I mean, linear search we have to do.
Okay.
And if there are less number of connections, then the linear list will be the length of the list will be small.
Okay. Yeah. Any other aspects? Yeah. Whatever you say. That's okay. Yeah. That's also accepted. Any other aspects? Okay. One more thing. How we here define is adjacency list will be based on like a list, like simply a list or dictionary data type, right? Yeah, whenever we are using
Yes.
dictionary, that will take more more space than compared to a simple array like data structure.
Okay.
So in that's one more aspect why we are using adjacency list. If you say, I mean, if you are storing a dense graph in an adjacency matrix, that space required will be lesser than adjacency list approach. That's also one reason.
Okay.
So can you repeat adjacency list will take less space than adjacency matrix, right?
Yeah. Okay. Okay. What I said is, whenever I say adjacency matrix, that will be a contiguous array. That will be a fixed thing. We'll fix it mostly in it will be like a 2-dimensional array. Okay. So where that will take less space compared to any dictionary like adjacency list. Here,
sir,
yeah.
but sir, we can also write adjacency list in an array form.
Yes. Okay, you can write that in an array form. One, what is the difference between adjacency matrix and adjacency list? There's no difference. There won't be any difference in adjacency list, right? Okay. Whenever they say like 1, 2, 3, whatever no, there will be a list that will be changing. The value will be changing. If you are appending, okay, if it's a solid also, that this data structure will take more space.
Yes, the obvious thing is the obvious thing here is the extra space for the keys.
Yes.
Of the dictionary.
Yeah, if it's a dictionary type version.
All other thing are in adjacency list representation. Here also n square and here also n square number of elements, but here keys are extra, I think.
Yeah, I mean it's based on space on the focus of space. Also, you have to search through elements, but that will be the same case in adjacency matrix as well. Let's say we want to know what are the nodes which one is connected to. You have to go through all the values. The one more way of representation is edge list. That's also, it's just a list of edges. I mean, based on your application, you can store it on AWS.
So we should use such kind of representation if we have disconnected nodes.
Yes.
And where the node are not connected to any other node.
Yeah.
Is it?
Yeah.
Okay.
Like that. But if you are using edge list, right, you have simply one node which is not connected to any other node. You can use it. I mean, there won't be an edge, right? Edge list will work only if it's a connected graph. If it's a disconnected graph, even if it's a simply one node is laying somewhere, then we have to use some different approach. I mean, let's say you can generally store as a tuple with like simply one tuple, like that. You have to use different approach. Then it won't be an edge. That's it.
Okay. So what is the benefit here in edge list?
Okay. Let's say there are some kind. Whenever you take an edge, right, there will be a definite pointer between where from to where. But if you are taking any adjacent list, you have to go through an approach, or go through and like go through the array, go through the row, or go through whatever list in there. That is based on your application. Let's say you are traveling from one city to another city. If it's a edge list, you can simply take, I'm traveling from this city to this city. If you want, if you are whatever the code you are writing is your application is much relevant to this edge kind of thing, then you have to use the edge list with respect to application.
Yes. In our exam, edge list is will not be there, right?
No. It's like just consider it as well. I cannot say there won't be any edge list. There may be based on logically.
I'm asking because edge list is not covered in the lecture, so.
Yeah, but you can logically. It also comes with like a list, right?
Okay. So we have So if we have to create the adjacency list from the edge list.
Yeah, I mean, whenever it is asked, right, it will be logically based on data structures. not with respect to much related to graph or like that, but the main concept that which is focused on is based on data structure. If you find your question is supposed to find the best data structure, whether it's edge list or adjacency list or adjacency matrix or anything, then you have to use it. You have to consider the edge list and its aspects as well.
Okay.
Let's say I'm giving you an example. You wish there are many same option. You have many train tickets, 10 train tickets. You want to give it to many persons. Then the application will be edge list. Each train is from one destination to one person, from departure to arrival, one place to another place. Then that train ticket will represent as a edge list, not like any adjacency list or adjacency matrix.
So, can you repeat this?
Okay. Okay, you have 10 train tickets. Okay. From various some city to some other city. If you want to give it to multiple person or like that, if you want to store this in some data structure, right? Then
Yes, yes.
if it's a small, so you can definitely use edge list.
Yes.
Because there is sure that there is one from and one from. We are simply storing the edges, not the nodes. That's one
Yes.
more thing we have to be in mind.
Yes, for small list, it can do in constant time.
Yeah. Okay. One more thing. If you take the transpose of the adjacency matrix, you can get the inverse, the reverse map. Similarly, how can you do it with the adjacency list?
What?
Okay, you want the reverse map. Okay, you have some graph A to B, B to C, A to C, or D, like that. I want the reverse graph, which looks like this. You have adjacency matrix. This this relationship is stored in the adjacency matrix and adjacency list. How can you get it this type relation?
It is like the connection swapping in the linked list.
Yeah.
So it should be in place, or we can make
No, it doesn't
another
matter.
matrix.
Yeah, it doesn't matter. Take your.
If we so
What
if
do
we
you do?
take
Yeah, what do you do to get the from this graph to this reverse graph?
so for each edge, we have to just swap the values.
Yeah.
But it will be n square in for adjacency matrix.
Yeah. Okay. I'm not talking about complexity. Not take the best complexity or like that. Just I'm asking how you do it.
Brute force technique is just go through all the elements and swap it. I mean, for each I in the rows and for each j in the columns. If I equal j, then just swap it.
Okay. What you are saying for every adjacent list and matrix, you are swapping it.
Yes. But
Okay.
I think there may be some better.
Okay. How about the transpose of adjacency matrix?
Transpose of adjacency matrix. Okay, it may be the solution.
Yeah. Okay. How about for adjacency list? What can you do?
Okay, so adjacency matrix, it is just the transpose.
Yeah. Okay. In the meantime, just work it out as well. Take one. We can simply make.
Yes. One example I will take an.
Okay, take the same example. Yeah. Here to all there. See. If you take the transpose of this one,
Yes, it's just the reverse.
I'm trying to know T2 A and B. It gives the reverse graph.
Yes.
Okay. How about adjacency list? Take the same graph. How can you get the reverse graph?
So for list, we have to create a new dictionary, and we
Okay.
can go through all the elements in the list and create the new adjacency list.
Okay. What you are saying is go through every element by element and create a adjacent one more dictionary. Okay. Is there
there's
any? Yeah.
Yes, that is the naive approach, but there should be some better approach.
Yeah. Whatever you said is almost correct. You already studied that what you are doing. Have something. Have you related with anything? Whenever you are considering with the dictionary, right? One very obvious question you have already seen many times as well. From CT, Python. It takes some time and recall what you have to do, what you studied. Just take some time because whatever I am saying this, right, this reverse map, it will come very handy whenever you're doing the some programming assignment.
Could you repeat the question, please?
Okay. I have say this graph. Okay. This graph. I want to reverse it. Change the reverse. I want to make into like this. Like that. I want to reverse the direction of the edges. If you are using the adjacency matrix notation, if you transpose the matrix, you'll get the reverse graph. That represents the reverse graph. But now you are using adjacency list, then what do you do?
Okay, so the problem is that it will take more space for getting the new adjacency list.
I mean, don't worry about the space or anything like that. Don't worry about that complexity or those efficiency. Just give me some algorithm or how you do it.
Okay, the naive algorithm I can say.
Okay, yeah, I get that. Which you studied some technique, which gives the answer. Okay. How about dictionary inversion?
Yes, that will work, I think.
Yeah. Okay, I'm writing the just inversing dictionary, whatever the some algorithm I learn. Okay. I go through this and take the first one. Take A and I going through T, then I'm going through say this element D. So
This is the naive approach, no?
yeah, it's naive dictionary inversion.
Okay, I thought this
What I did
approach.
is I gone through this each value and
Yes, this.
I used the key as a I mean that is corresponding list, the value list in the appended it to the list, which was
Yes,
in a
yes.
value. Yeah. Okay. Okay. Do I lack something here?
Yes, some keys are missing.
Yes. What does it represent? I mean, I'm asking for in a programmatic approach, not just a general. I mean, if I inverted this one and use it here, do I get any problem when I am doing writing a program in Python?
Yes, if we reinverse this new dictionary, the C mapping to empty list, that information will be missing.
Sorry, C to
empty list. The information about the C node.
Okay, no, okay. Okay. If it's a graphically mathematically, no loss is there that I can confirm. Because okay, I'll make the map. You said C to empty list mapping is missing, right? But in a reverse graph, there is no thing. B to A, C to A, T to A, and T to B. Nothing I lost. In terms of what I'm saying, mathematical in terms of graph aspect, I didn't lost anything. But when I write a program, did I lost anything? I mean, did I get any problem with it?
You will miss the A node.
Yes, but what will it cause? I mean, what will it? This will throw any error? Will it bring any wrong result? Yeah, actually, okay. When you miss a key, right, it will throw a key error generally Python. Okay, because these kind of the things we normally do when we are do programming, then we have to realize and change. So whenever with respect to graph, programmatically, if you are doing any inversion, they first initialize the inverted dictionary with all the nodes. then proceed the adding values there. Because it will prevent some time when we do the writing the algorithm. It will surely helps you in the programming exam or like that.
So can you repeat the approach?
Okay. Whenever
Just the last line.
okay. If you are doing a dictionary inversion, right?
Yes.
Okay. First, I have some A list, adjacency list. It should have something in it. If I have inverse A list, then initialize with all the nodes.
Okay. All the nodes with empty list.
All the nodes in A list with empty dictionary.
Yeah. Okay. Got it.
Yeah. If you do that, you will not lose the problem. You will not miss any key. Just appropriately appended correspondingly. Yeah. Append the element, edge transfer it. Like that. Okay. This dictionary inversion will help you when you are writing any program, right? When you want to find the parent or what are the, if your question is like, where should I go from A? Then you can use the simply adjacency list. Then your question changes, where are the places where can I come, where can I reach A? From what are the places I can reach A? Then you have to do the inversion. Then figure out the value.
Yes. And sir, what is the time complexity of transpose of the matrix and the list inversion? Yeah, sorry, dictionary inversion. It will be O of n. Right?
Okay. Yeah.
O of mn. I mean, all the nodes.
Okay. It's like a
Number of edges.
total sum of values.
Yeah. And for the matrix, what will be the time complexity of transpose?
It will be, let's say, m rows and n columns. Then it will be order of mn only.
Okay.
Yeah, because you are simply taking this and doing it. We are not doing any much complex thing. We simply changing the index. Based on the index, we simply do it.
Okay.
So it will be order of mn.
Okay, so in general question, like to find the parent, we should use the BFS technique.
Yes, but the parent, okay, that parent dictionary, right, that will give only one detail, where you are coming from. There may be a case
Yes.
that, let's say, consider this graph. Okay, for A, B could be a parent, D could be a parent, C could be a. But based on whatever the BFS or DFS you used, that will, based on the way the parent will be set. That give based on the way you gone to A. But if you do the dictionary inversion, you get all those nodes from where you can reach A.
Okay.
Yeah. If you do the parent, you will get some either of B, D, or C. But it's based on requirements, whether it is required, whether the parent is required or this inversion is required. Okay, parent is much required when we are going through some path. Some path is involved.
Yes, some path.
Yeah. If some path is involved, then you have to use the parent. But it's a general thing, you have to involve what all the nodes which I can visit are these kind of things, then you have to use the parent. This dictionary inversion or regular adjacency list. Okay. Also, some grade of the exam assignment also mainly uses this.
Yes, sir. Can you discuss the GRPA? 2 and 3 sir, both GRPA. GRPA 1 and 2 I did, 3 I didn't get. But
okay,
in 2 I not cleared all the test case, private test cases. Only 3 is passed.
okay. I'll explain 3.
Two and three both.
Okay. Okay, I'll remove this Q part. This function is a dictionary inversion function, which have the list as a value. If it's a list value, then it will invert it accordingly. Because whenever you do the dictionary inversion, right, more often that key and value will be like a key will be some integer or like that immutable value. The value is also key is an immutable value, as the value is also like as integer or string or like that. But here, with respect to adjacency list, the value is adjacency list. So this algorithm will invert if the value is a list. It is, you are clear with it, right?
So can you explain it? I mean, I did the topological sort here.
Okay. Yeah.
So
Yeah, that also.
how I can approach this one? I mean, I thought that topological sort can do it.
Yeah. Topological
So
sort also. Yeah, that also. Okay, it's just like a topological sorting only. Yeah. You find the least path and do that. But the thing is, here I use the inverted adjacency list because I know the what are the end level. I mean, we know what is the first point we are starting based on topological sorting, which are the possible points. We finally figure out what final end that have the distance value. Right? From that, we are coming backwards. Once I reach the last one, as per this question, it is Kanyakumari. Then I am searching for the places. What are the places Kanyakumari can be reached from? Then I found the what are the neighboring cities. Then among that, whichever takes the the biggest path. So that's where we are backtracking.
So can you take one example and explain this how it is going? I mean the visualization.
Okay. Yeah.
Hello, sir.
Yeah, I'm taking the visualization.
What I have done here, that I just calculated the in degree, and if one node is with in degree 0,
Okay.
then I return that solution, that node. So what extra it needs, and I mean the corner case.
Okay. What you said is correct, but what the program did is do the backtracking. Okay, I'll show this visualization. Okay. Okay, this is the visualization of based on the topological sorting, right? What is the longest path? This the super the value on the top right corner denotes what is the longest path here. Based on the topological sorting, we'll know lay is the starting path. For the longest path for days, which is the node with 0 in degree. So we are starting from here. Similarly, like these are the only way here. So after I reach Delhi, there are 3 parts of splitting. The important thing is here.
Okay, so it is that question number 3, right?
Delhi to Agra, then directly to Ranthambore.
Hello, sir.
Yeah,
It is question number 3, right?
yeah. That long
Okay, I
journey,
thought
right?
that. Okay, I thought that question number 2.
Okay, so it's question number 3. Long journey.
Okay.
Okay. So the from Delhi to Ranthambore, the shortest path will be Delhi, Agra, and Ranthambore. But here we want to find the longest path. The journey to be very long. So we are coming this way: Delhi, Jaipur, Pushkar, and Ranthambore. So similarly, we do all the longest path for the each cities. Finally, we find the what is the how we find the it is the end cities which have the longest path, which is Kanyakumari. Then I so far I figured out this graph. How can I backtrack it? Okay, I'll explain. Okay, I'll explain it here. Then just a minute. Okay, just yeah. Okay, once I reach the last point, right, then I have to figure out what are the possible ways I can reach Kanyakumari. I mean the what are the pre-nodes? One is from Madurai, one is from Thiruvananthapuram. There are 2 edges here. So for this reason, I'm using the inverse adjacency list. You get it? Then within the
Is it like the dynamic programming question? The grid path, like
yeah, the approach will be like similar.
Okay.
Yeah, but I mean I have 2 choices, right? One is Madurai, one is Thiruvananthapuram. Then the choice I am making is whichever has the longest journey take. I mean, which is the longest path. Then I am choosing the Thiruvananthapuram from Cochin. Based on that, only one value here. Then from Cochin, there are 2 ways. One is Madurai, one is Goa. Among these 2, take the longest one. In that way, I'm just backtracking based on the Chennai, Bangalore, then Goa.
Okay, we have to backtrack.
Yeah, we have to backtrack. But with respect to this question, there is only one unique long path is here. That was set in that way. So in a real-time approach, you have 2 or more paths will be there in the based on the same approach.
How can I ensure the longest path?
Okay. How? I mean, if you do the backtracking, right, it ultimately gives the longest. Okay. There is no. I can surely there is no way that you can reach the some. Let's say I say Khajuraho. Okay. Then there is always there is a node from you are coming from, which have the value of 8 minus 1, 7.
Eight minus. Can you explain this portion? I mean,
Okay. Okay, I'm in Khajuraho. Okay. I want to come from a city. Okay. There is at least one city. Its longest path will be the Khajuraho's longest path was 8. So one city that have a longest path, which is 8 minus 1, which is here it's Varanasi. That is sure, because unless without the city, you cannot reach here at 8, at the longest
yes,
path of 8.
yes,
I mean, this is the proof of validation you can do. But if you wrote the algorithm which finds the value of longest path of 8 minus 1, longest path minus 1, then you can come into a decision, because there is a 2 possible case which have the same longest path. Let's say, assume that Ranthambore also takes 7.
yes.
Then you have to take the decision. But here it is made unique, so it won't be there. But if it's a real-time general approach, general problem, then that will be there.
Okay, so we have to do minus 1 for each and take the
No.
least
Yeah.
value.
Okay. Yeah. What I will, yeah, that will work. Yeah. But with respect to this problem, so what I will suggest is, if it's a very general approach, right? Not like this one perfectly unique path is there, then you have to take all the consideration. Among that, you have to go backtracking. Let's say this Varanasi takes 7. Assume that Ranthambore also takes 7. Then you have to go to these 2 cities and figure out its previous city. That way also
Okay.
works. Yeah. You can choose either path. Right? Even either way also works. Because either way it will give the longest.
Okay.
Yeah.
Here it is because the starting and ending. Sorry, the ending, starting and ending node is mentioned.
I don't think so. Okay, I'm not sure. No, it is not mentioned. You have to find it.
Okay.
You are clear with this, right?
I think clear. I have to. I mean, recheck this.
Yeah, just go through this code once again.
Yes, yes. The central idea is backtracking.
Yeah. Maybe any other approach without backtracking also maybe there. Yeah. But how here we implemented is using backtracking.
So what more we can implement without backtracking? Like, can we solve this using dynamic programming?
Okay. Yeah. We can do solve it using dynamic programming because it's a DAG, right? So we can.
Yes, yes.
But that filling the table will be not easily. not I'm saying easy or like that. You have to use some other data type. In generally, what we see is in the table, the values will be always some integers, right? But
Yes.
here you have to use a list.
List of strings.
Yeah. I mean, you can try on your own, but you can definitely do that. But for that, what you have to do is you have to go from the bottom up. You have to know what is the last value. I mean, at least start or last. You have to do that. You have to figure out which one is the start, which one is the last.
Okay.
Because with respect to this case, right, you don't know. You have to figure it out.
But in this case, if we do backtracking, how can I know that what is the last position and what is the first position?
Backtracking, right? I mean, if you do the topological sorting based on the longest.
Okay, first we
Yeah.
have to make. I mean, create the in degree list.
Yes. Based on the integrity list, you will be choosing which. Okay. Yeah. There are
But
the
there
minus
are.
one. Yeah.
But there are more than one in degree. Okay, in degree. Okay, so if in degree list is 0, then in degree is 0, then it is the starting.
Yes.
But there are more than one nodes which have I mean which points to null. I mean after that there are no other nodes.
Yeah. Okay. What here we do is we take the longest path thing. We assign the longest path for each one. This is exactly the topological sorting.
Okay, okay.
Yeah.
So okay, so we just have to apply the topological sort.
Yes. I mean, that's how we find out the zero integrity nodes and do all this.
Okay, I thought about topological sort, but okay,
I
in
mean,
topological sort we have integers, but this is based on string value, right?
no. I mean, these are just nodes, right? It doesn't make any difference. Okay. What you are referring is just A to B to C, 0 to 1 to 2. It doesn't make any difference, right? With the topological sorting. Just a order. It's just a labels we are giving.
Yes, yes, okay, okay. Topological sort.
Yeah. For the only thing we have to know is it should be a DAG. That should be a director graph. Director acyclic graph.
Yes.
That's it.
Yes.
Okay.
So now can you take the question number 2, GRPA 2?
Okay. It is the finding the master term, right?
Yes,
What?
sir.
Yeah, what you have to do is
What
here
I-
also the same thing. You have to
So what I have did,
Yeah.
yes, sir, I did this, but all the private test cases are not passed. Only 3 has passed. Actually, I find out the in degree and take that node which has in degree 0. So
Okay,
what the
I
corner case I
understand.
missed?
I get it. What is the mistake you did? Okay, actually, based on the description, right? Based on the problem statement, master tank is one. It doesn't have it now. If it's a simply it's a 0 degree, it doesn't mean it's a master tank. If you pour the water over the master tank, it have to flow through all the tanks, all through the remaining tanks.
Okay.
Okay, let's say it is 1, 2, 3, 2. Okay.
Sir, screen is not visible.
Okay, sure.
I mean,
Yeah. Okay, these are 2. Four. Okay.
yes, sir.
If you pour water into 2, it won't reach. Let's say it's 5. If I pour water into 5, it will not reach 2 or 3 or 1.
Yes.
Yeah. Okay. Then definitely 5 is not a water tank. I'm just giving a case.
Yes, yes. Then what should be the correct approach?
The correct approach should be you have to find whether it is you can reach all the nodes from one as well. You have to check that as well. Just start implementation. One thing you can do is you can brute force way of approach will be go to each node and apply a DFS whether you can reach all the nodes.
Okay,
That's
so
one
n
of it.
square, n
Yeah.
square algorithm.
Yes. Yes. No, it will be n cube.
Yes, yes, n cube.
N cube.
Sir, I used a BFS approach where I made the from one node, I made a list of all the reachable nodes and check the length if it's n-1 or not.
Oh yeah, that's also right.
That will also be n cube.
Yeah, that's also n cube.
But how to approach in this optimized way?
Okay, I am not even sure for the. I'll just try to figure it out. Okay, here it's up. Or else you can do the topological sorting. You can reach all the nodes. Okay, the solution which I provided order of n and n plus m.
So we can also use an approach if we know that the master tank will be the one which will be among the ones which
Yeah,
has
zero
zero in degree.
Yeah, 0 degree nodes. Yeah, we can figure it out what are the 0 degree nodes and 0 degree nodes, and we can do the DFS from that. That also works. We can do a DFS and whether check we can reach all the tanks from that or like that. Yeah. Okay, yeah, just go. Okay, how we are doing this? We are going from one node to another node. We are checking whether we can reach all the tanks or not from that using the DFS. Okay. Okay, the better approach, one other approach is what I will suggest is memoization. Sure. I mean, whenever you do a 0 integrity node, right? You can do one approach and do a DFS for it, where memorize the value, how many tanks you can reach it, or else simply you can reach all other tanks which is below them. For this,
for the 0 integrity nodes.
yes, for all 0 integrity nodes. Not even for 0. I'm saying what for all the nodes.
Okay.
I mean, if you are doing 0 integrity nodes, because we are doing only one time, right? Say 0, 1, 2, 3, 4, 5, or like that. If you do the memo of 1, then can you reach all the nodes? Then if you come doing another 0 integrity nodes, then if you come across 1, you can immediately get it. That's one more good approach. You don't need to go through all the tank whether it's reachable or not. It is fixed that if you go 1, you can reach this many tanks. Can you get it?
So, I got the hint, but can you just write a kind of pseudocode for this?
Yeah.
I mean, I got the hint that
Okay.
in the previous approach we were finding for all the tanks, and here once we got the tanks from A, is from 1. That how many tanks we can reach from 1. Then we can we do not need to find for the next tanks.
Okay. Okay. We'll do DFS with I. What I'm returning some value X. It have the information about what are the tanks which I can reach about. Memo. I am taking a memo of it. I'm storing the X. If I do the, okay, let's say, so have you understood this part, this memorization part?
Yes, this part is clear.
Okay, so I have 3 0-degree nodes. Okay, zero, 1, 2.
But sir, one thing here that if we have more than 1 0-degree nodes,
Yeah.
then there cannot be any answer because we have to find the node uh, from where all the tanks can be filled. So if 0 is the answer,
Yes,
then
yeah, agree. Yeah, actually, the test
so
case was more subtle than that. Yeah.
so that's why I didn't get that why 3 only private test case passed.
Okay. Okay, there is a case that if return 0 if no master tank exists in the system.
Okay.
In this case,
No.
right, there is no master
Yes.
tank. There is
Yes,
option
no
also,
master
right?
tanks.
Yeah.
But I put there a return 0. I mean for k in degree dot keys, if in degree k equal 0, then return k and then return 0 after the for loop. I did this.
Okay, if you found 2 integer 0 integer nodes, you say simply return no master tank, right?
Okay. I got the mistake in my code that if I put that if in degree is 0, then return k. So that should not be there.
Okay, yeah. Okay, it's from
Because in this condition there are no master tanks, but
Yes.
according to the code I have written that if it first check for 0, then it will return 0 as the output.
Okay.
Because if I do then return the node which has in degree 0, right, in this example you have drawn here 0 will be returned as the answer, but the node 0 cannot be answer, right?
Yeah. Yes.
So how can I maintain that portion? So should I check that number of 0-degree nodes?
Yeah, you can do that.
If
Yeah, you
there
can.
are only 1 0-degree nodes.
Yeah, you can try that algorithm. Actually, it is in graded, right? Okay.
Yes, sir, it is in graded, but can I get the private test case?
Yeah,
I
it
mean,
is
private test
provided.
case.
Yeah, it is
Data.
provided in the portal itself. You can download the zip file of it. There is a button called download all.
Oh, yes.
You can download all the test cases into.
Yes, sir. Yes, got it. I will check it that if it works or not.
Okay, sure.
And the solution code is given here. That is little bit difficult, I think.
I mean, if it seems difficult, but if you go through the code, right? Of course, it will take some time. Just
Okay, I will go through it.
Yeah, because in the future you have to write a much more unclear codes as well. Because the one part of the programming or coding is reading someone else's code.
Yes.
Yeah. That's one more reason we are not giving more commanded codes as well. Yeah. If its comments are more appropriate, it will be there. Okay. Yeah. Actually, we reached the time. Okay. Do you have any 1 or 2 questions? I'll clear
Yes,
it.
can you extend?
Sir, I had a question
for half an hour.
Yes. Yeah. Extension, I'm not sure because otherization we don't want to overlap with it. Yeah. If you have any small doubt or like, I'll clear it out and end the session. Yes, Sandeep. What's your doubt?
I was trying the practice mock for the practice proctored exams.
Practice Pro. Okay.
Okay, so the mock for programming exams. The
Okay.
fourth question. The fourth question had this question of. I'm sorry. The third question had this question of back and forth. There
Yes.
is a adjacent list. There is a source and a destination, and I have to enumerate the number of paths there exists
Yeah.
between these two elements.
Yes.
So what I was struggling with is suppose the source vertex is 0 and the destination vertex is 1.
Okay.
The example that is given there, and 0 had 3 neighbors, 2, 3 and 6.
Yes.
So amongst these 3 neighbors, 3 and 6 had 1 as another neighbor. So the two straight paths are 0, 3, 1 and 0, 6, 1. The other neighbor of 0, 2 had a longer path to 1.
Yeah.
Okay. So there are 3 paths.
Yeah.
But I can also have a path where I would go to from 0 to 2, then to 3, then to 1. So in this path, I am touching 2 of the neighbors of 0.
Yeah.
If I enumerate this path, then I am cutting off 2 and 3 from any other path, because as per the condition given in the question, I cannot visit another node in between 0 and 1.
Yeah.
So how can I control that? See, if I have a path, or if I have a path which consists of vertex 0, 2, 3, 1, then I can only have one more path. So number of path becomes 2.
Okay. I get it. You have one more longest path which lead you in trouble later, right? You want to avoid that.
No. My question was, I was trying this question also there in the live coding session. So I visited this question before. So I was, these are the few, this is one of the few questions that I haven't been able to solve.
Okay.
I can see the 3 paths that you have enumerated in the answer, but if I run a DFS, now in the question you have given that then there will be a BFS and there is also a suggested list, cost prevention list, which somehow we have to exploit in order to enumerate this path. That is something that I understand. This was not there in the live coding session version of the problem. So I tried DFS, and every time I visited 0, then 2, then 3. So 2 and 3 vertex were being part of one path. So there is only one other path that was there after this path is enumerated.
Okay.
I cannot enumerate 3 paths.
Okay. In that case, right, what I would suggest is take the smallest path, shortest path.
Shortest path. Okay.
Yeah. How can you get it shortest path in unweighted graph?
BFS.
Yeah, BFS. Yeah, that's how you can do that.
Okay. First, I'll have to enumerate the shortest paths.
Yes. Because once
so I have to enumerate all paths, then I'll take the shortest paths which are disjoint from each other. The intermediate vertices are disjoint from each other. Is that it?
Yeah. And whenever you're doing a BFS, right, you take the, I mean, once you do the BFS, once you get even in an optimistic way, if you see one, you can simply stop it and get back it. After that, you take one more path, leave out this 3 and take the another path.
Okay.
So in this case, another case it will be 0, 6. Thereafter, there more way. So at least one.
It's 0, 0, 3, 1, 0, 6, 1 and 0, 2, 4, 5, 1.
Yeah.
These are the 3 paths in this graph.
Yeah. So it's a back and forth. You don't need to go start from 0 and 1. Then you have to start from 1 to 0. Either way, it's a undirected graph. So it works. Starting from 0 to 1, 3 times, multiple times, that works.
Where can I get the solution code for this?
Actually, for Mark, we are not yet provided yet, but it's a live coding problem, so you can get it from the Replit teams. For this problem alone, you can get it from Replit teams, but for the other
Replit teams, okay.
Yeah.
Now, for the other question, I have solved. This question, I couldn't solve. Okay, thank you.
Okay. Yeah. Actually, we don't want to extend the session so far because other live sessions also happening on 7 after that. So if you have any more doubts, post it on Discourse and like that. We'll answer it as soon as possible.
Okay, sir. Can you say just last some suggestions that how should we approach or how should we prepare? I mean, the
For
programming
programming
assignments
exam?
I'm getting little difficult.
Okay.
Yes, sir.
Okay. First of all, if you have enough time, please go through the assignments and not. I don't want to go all this. Just to get to know what is the algorithm involved first, because once you fix what you are going to do, writing the program is not that much difficult. Once you get the error, you will sort it out. First, figure out the algorithm first. If you want to train it, go through the previous graded assignments and go through all the live coding questions. Just figure it out. What are the algorithm first and do it left. If you don't have even time, just figure it out algorithm and validate your algorithm for all the test cases.
Okay. Okay.
Then comes the programming part. I mean, if you are well versed with programming, if you know the target, what you're going to do, you can write a program. Then it's not a big issue. Just figure out the algorithm. That's enough for now. Anyway, you have to need a program. But if you are not much good at programming as well, then write your algorithm, do the programming, go to the next problem.
Okay.
Yeah.
Okay,
The
sir,
practice
thank you.
questions and live coding questions are a very good source because you can write the program there itself. For a graded programming question, you have to use your own. You have to download the test cases and do it on your own.
Yes. Okay. Okay.
I mean, don't expect it's easy for that. Just it will be testing your knowledge as well. It's a big part of exam, right? So
Yes,
be
and,
prepared for
sir,
anything.
how will be the difficulty level of the programming exam?
Yeah. I mean, it will be like you are capable of doing that, but I want you to consider, I mean, how to manage the time, because it's a programming exam. You have some question, you have to manage the time for each question appropriately. So I can't disclose anything now. So expect a reasonable difficult question. Difficult exam. I'm not saying difficult or like that. Reasonable exam from a student perspective.
Okay,
Yeah,
are we
I have-
supposed to? Sorry. Are we supposed to remember all these standard algorithms? Like, I understand we have to remember and if required deploy these algorithms like BFS, DFS.
Okay.
Like
Yeah,
a
in
tree.
that case, right? If it's a targeted on the whatever the algorithm it's provider, then if it's targeted on specific
Okay.
algorithm,
Okay,
there
okay.
won't be any provider things will be there.
Okay.
But if it's
Okay.
targeted on some other techniques, but that require BFS or DFS, then it will be
Okay. Okay. Nice. And things like the algorithm where the rotation of the AVL tree, or Dijkstra, this sort of algorithm, do we need to remember?
I mean, what I will suggest is there won't be like a 100 lines of codes you have to write. It should be reasonable. But whenever you require any algorithm, if that algorithm is required, that will be provided. But better you have to use practice with the very standard all the BFS, DFS, and those things.
Okay.
I mean, some things will be you have to use a lot, right? Like Dijkstra.
Okay.
I mean, better practice with them, but there will be partial codes. You don't. If it's a very lengthy problem, you don't need to do all things. Only the focused things.
Thank you.
Sir, I just have one query. Will the size of the test cases will be mentioned, like how large will be the size of the test case for which you have to write the program?
Okay, if we want you to write always try to write a better efficient code. but there won't be any specific mention on question. If we are expecting on a specific like a complexity, you have to write this. It will be mentioned. It will be
So
mentioned.
if you are going to use recursion for some, if the size of the test cases will be mentioned, then it would be easier to import the system and increase the limit, recursion limit.
No, increase it to your maximum limit as you can. Even this case, right? Even the recursive case, you can maintain 1,000 with you can do a very large operation as well, but it's not fair. In that case, right, you can increase it to a maximum limit as possible.
Okay, so whenever we use recursion, we increase it to the maximum.
Yes. Okay. Also, yesterday I think there is a session about operationally how to do the programming assignment, all those things. Just right. If you have any doubt, see that as well. Okay. I'll wind up the session and thank you all. Yeah.
Yes, thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.
For the exams as well.
Thank you.
Yeah. Bye.